Okay, hello again. So this time we will solve another Cyber Defender CTF. So I've missed solving a deeper investigation type. So I go back to cyberdefenders.org CTF. This time we are solving the seized CTF. Okay, so this is a memory analysis CTF. So we will be using Volatility, CyberChef, and grep to solve the 9 questions. Okay, let's start. So first, of course, you have to sign up and download in order to download the challenge. Okay, and once you have downloaded it, you can extract it. So notice here, this is the actual extracted output, dump.mem. Okay, so first question. So not much challenge details, as you can see. So we can go ahead and deep dive. Question 1. What is the CentOS version installed on the machine? Okay, so for this one, remember that for a memory image, everything is in clear text. So we could easily grab keyword Linux release in order to search for the keyword related to what CentOS version is in the memory image, right? So let's try. And as you can see, it's highlighted in red. We can see here this one specifically, Linux release 7.7.1908. Okay, so actually that's the answer. Okay, I've answered it. Refresh, let's refresh. See? Alright. Okay, so for the next question, I forgot. We need to copy the provided profile in order for us to really read the contents of the memory dump. So to do that, of course, first download the image and extract it using the password cyberdefenders.org. Once that is done, okay, you will notice there will be an output. There will be an extract file named CentOS version.zip. So what we need to do is copy this to the business instructions here. We need to copy it in the volatility path / volatility plugins overlays in Linux. Okay. So to do that, okay, let me just clear this. So if you're not okay, let's just assume from scratch. Assuming you do not know where you have installed the volatility, so what you can do is use find, right? Just to find where's your volatility directory. Oh, sorry for the typo. Volatility. Okay. Alright, so just let it run and found one related directory, so we can use this directory. Let's verify if it has the related directory. Remember cd volatility. We have plugins overlays Linux. Plugins overlays Linux. Right? So we need to dump the profile here. Copy the profile here. So to do that, okay, let's for a while. Do that. Okay, what we're going to do is to copy it using root. So it's in home dfir downloads CentOS.zip. copy it over to this path. It's quite long, so we will use highlight, Control Shift C, Control Shift B. Okay, verify. Now it's here. Okay, CentOS. Let's check. Okay, let's check. I checked a while ago using bold.py, grep Linux, and the directory for CentOS was not yet found. So let's try now again. And now, as you can see, we now have the CentOS profile. Okay, let's check if we can read the memory dump using that profile. Okay, I have here bold.py-f dump-mem --profile, the Linux CentOS profile, and the basic Linux PS listing, right? So let's see if we can now read the memory image using that profile. And voila, that there. So we can now answer the remaining questions using this custom program. Okay, so now that we got that out of the way, so we can now answer number 2. I've actually found it already, and then I'll just walk you through the video. So there's a command containing a strange message in the bash history. Will you be able to read it? For this one, what we're going to do is, okay, if I will clear again. So since we're dealing with bash history, what we're going to do is use this command. Okay, so bold.py-f, the memory image, dump.mem, the profile, custom profile. Then we use the plugin Linux bash to see the history of commands, right? When we run this, it will give us the following output. Okay, it's taking some time. Wait. Okay. So notice here, anything suspicious. So if you are working in a SOC, definitely any base64 screen is worth investigating, right? Because that could be an obfuscated malicious command. So what we're going to do is simply copy this, copy the base64 string, and go use a base64 decoder. So I've did it already. Notice here, here's the decoded string, and that's how we got the answer. Okay, so next, what is the PID of the suspicious process? Okay, so here we can use the basic. Okay, let's try use the basic Linux PS listing. But the thing is, you really need to know what you're looking for, because this is a manual eyeballing inspection. Okay, so anything out of the ordinary, you notice here, this is quite a lot actually. Okay, but another thing that you can do if you are having a hard time looking at this is to check the network connections. But this time, we will limit it to those listening or established. Okay, this is the command. Okay, let's run it. And as you can see here, we just have to inspect a fewer ones. Okay, and notice here, this is normal system, RPC, SSHD. These are commonly usual normal processes. And then when we see this one, right, the infamous and cat, commonly used as backdoor, right? And this is the process ID, which ties up to this one, ncat. Okay, so that's how we got the answer to 851. Okay, next up, the attacker downloaded a backdoor to gain persistence. So what is the hidden message in this backdoor? So what we can do here, recall we inspect the Linux bash history, right? So we found this, if you remember, on the earlier question. I notice here there was a script downloaded, so this one. So what we could do is we could download the same script, copy, make sure there's an install git in your analysis machine for this to work. Okay, it will be downloaded, so we can go to the Python backup, cd, okay, then unzip. Oh, it's already okay. Okay, once we have downloaded it, okay, check the contents, like in the bash history. Okay, so check the contents of the Python backup.py. Okay, no, nothing seems to run here. Perhaps it was reorganized. So check the contents of the other folders. Okay, let's see. Backup.py. Okay, nothing, no URL or suspicious anything. Okay, how about we start from the last file, snapshot.py, and a quick inspection here. Okay, bingo. You see here wget to a pastebin URL. Okay, let's try this pastebin. Okay, let's see what's the contents of that. Okay, so it's a base64, and notice there the net ncat command. Okay, let's try to decode. Okay, if we decode it, oh, we found the answer. So that was a dumb backdoor. Okay, that's a cool answer. Okay, next, what are the attacker's IP address and the local port and target machine? So recall here, since we have identified netcat as the malicious process, so let's see the running processes using the linux underscore net command. Okay, then we will grab for the netcat. Oh, sorry, ncat. Okay. Oh, sorry, I need to be in the right directory. Okay, let's try that again. Okay, probably okay. Now we got the result. So the answer is this one, 192.168.49.1, and actually the port is 44122, but in the answer, it's accepting the source port. Oh, local port. Oh, that's why the answer is local port 12345, right? So that's why it's 12345. So okay, next, what is the first command the attacker executed? Okay, we found this. Let's go back. So this one we were to get we'll again list the running processes. Okay. Okay, so if you recall, the netcat command is the malicious process and used for backdoor. And then after that, once the connection was established, we are looking for the first command, right? And notice here, bin bash is used to run commands, scripts, and so we are looking for the process 2886. And these commands are in sequence based from the process ID. So right after the netcat backdoor connection, bin bash was run, then this script was run. Okay, so 7, after changing the user password, we found the attacker still has access. Can we find out how? So this is the clue. Okay, this is the answer. So notice here, garbled word, but resolves to rc.local, and that's what I'm going to discuss next. So the common persistence mechanisms being used in Linux is the use of etc/etc/rc.local. So adding entry there will make the configuration persist even after reboot. Or another thing is adding of local SSH authorized keys so that you could bypass the authentication. Okay, let's see. So we have here the process tree, right? Then you're interested in doing a string search on the commands. So let's try to dump the memory map of the bin bash. So to do that, Linux, wait. Let's try to, okay, dump that process. So 2887. So first let's create a dump directory. Okay, let's check. Then we can now dump. Dump Linux dump map dash p. Process ID is 2887. The bin bash. Then dash dash dump dash here. Let's dump all the contents into dump directory. Extracted. Then click run. Memory extract. So now that's done, let's go to the dump directory. Then let's do a strings extract, strings dash a for all the files. Store it on a strings.txt. And then once it's done, we can now inspect the content for strings related to persistence. So remember, the first persistence I told about is related to SSH authorized underscore keys. And as you can see here, okay, SSH key was added to the /home Kevin directory. So meaning the attacker no longer need to authenticate or enter credentials when doing an SSH connection. So that's one, but that's not the answer. The other one is actually based from this. So since we are looking for something like this on the answer, definitely it is something that is encoded. And when we're looking for encoded string, normally look for, let's do a wild search for the equal sign. Okay, so this part needs some manual eyeballing, really. So find the answer somewhere around the top result. Of course, if you have better ways of searching for base64 string using grep, uh, you can also do that. And we can actually find the string right here. So just bear with me a moment. Right here. Okay. Now displayed and base64 string. So we could copy that, Control Shift C. We could do an echo, Control Shift V, do a base64-D, meaning the code. Okay, for number 8, what is the name of the rootkit the attacker used? So we are able to find it. So when it comes to finding rootkits in Linux, we will use, uh, inspect or investigate system calls or syscalls, and the plugin for that is Linux check syscall. So a rootkit is actually a kernel level malware that allows the attacker to really modify the behavior in any way the attacker wants. So if it wants to hide the malicious process, it can do so. If it wants to kill or do almost do anything the attacker can imagine. So these are a more dangerous level malware. So if you want more info about it, I recommend this article. It's called table hijacking in Linux or Linux kernel module rootkit. So it has a lot of juicy info how you can understand more uh, regarding Linux related rootkits. Okay, so I've actually run the command prior because it takes quite a time to load. So this is the command to use. Okay, so the standard bold-py-f.mem in the profile, and we'll use the Linux check syscall, and we will grep for the hook keyword. Okay, and out of the results, we actually found this. Okay, and if you will Google this is not a standard Linux syscall, and it was found to have hook 88 times. All right. Okay, the rootkit uses CRC65 encryption. Okay, so what is the key? So for this one, I did use the hint. So this is quite a hard. So we have to use Linux lsmod. Okay, plugin, and we have to grab. So for that, we have to use this l-p, then grab -a1. Then we have to grab this keyword, the rootkit. So copy, paste. Okay, just wait for it. Okay, and as you can see, we have found the CRC65 key, which is this one. Alright, so we have completed the challenge. Okay, I'll do that later. So congrats. So hope you learn a lot. Okay.